The universe, with all its untold mysteries and unfathomable vastness, continues to leave scientists, astronomers, and curious minds alike both awestruck and perplexed. For centuries, humanity has sought to unlock the secrets of the cosmos, building models and theories that explain how the universe began, how it functions, and where it is headed. Yet, with every new discovery, it becomes increasingly clear that the universe doesn't always behave according to the rules we have set. In fact, as the most advanced technology in human history, the James Webb Space Telescope, JWST, continues its exploration of deep space, we are witnessing new cosmic phenomena that defy our understanding of physics, astronomy, and cosmology. The JWST has granted us an unprecedented look into the most distant corners of space, offering infrared views of galaxies, stars, and even exoplanets, many of which formed billions of years ago. This remarkable telescope has helped uncover a universe far more complex and dynamic than we ever imagined. It has shown us galaxies that are older, bigger, and more massive than we thought possible, appearing mere hundreds of millions of years after the Big Bang. These revelations are shaking the very foundations of our current theories about the universe's formation and evolution. For years, scientists believed that galaxies couldn't possibly be as massive as the Milky Way so early in the history of the universe. According to established models of cosmology, galaxies needed time to grow and evolve. However, the discoveries made by the James Webb Space Telescope challenge this idea, revealing that large, complex galaxies existed much earlier than expected. The question now arises, how could these massive galaxies form so soon after the Big Bang, when the universe was still young and the ingredients for galaxy formation were just beginning to come together? This isn't the only puzzle that JWST has presented to scientists. The telescope has uncovered strange and unexpected phenomena in distant galaxies, including black holes that were already over 1 billion times the mass of the Sun only a few 100 million years after the Big Bang. These supermassive black holes, which would normally take billions of years to grow, are another enigma that forces scientists to reconsider their theories about the early universe. But perhaps the most mind-boggling discovery made by JWST isn't found in the stars or galaxies, it's in the very nature of planets themselves. For most of human history, we have understood planets to be objects that orbit stars, forming in the protoplanetary disks around young stars. This has been the prevailing theory of planetary formation for decades. However, as JWST looks deeper into the cosmos, it is revealing a strange new class of planets that break all the rules. These rogue planets, as they are called, do not orbit any star at all. Instead, they drift freely through space, untethered by the gravity of a parent star. This discovery raises profound questions about how planets form and evolve. Could planets like these rogue worlds be common in the universe? How do they survive without the energy provided by a star? These questions have led to new lines of inquiry and challenges to our traditional understanding of planet formation. It turns out that these rogue planets may be far more numerous than previously thought, and they may offer new insights into the processes that govern the birth and life of planets. The concept of rogue planets isn't entirely new, but JWST's discoveries have brought them into the spotlight in ways we never expected. In fact, JWST has uncovered a surprising number of these free-floating planets in our own cosmic neighborhood, particularly in regions like the Orion Cloud, one of the most active star-forming regions in the Milky Way. The Orion Cloud, located just 1,350 light-years away from Earth, is home to thousands of young stars and countless gas clouds. But it's also a hotbed for rogue planets. These free-floating worlds are not gravitationally bound to any star, yet they seem to form in large numbers, often in pairs or clusters. What makes the discovery of these rogue planets so astonishing is the fact that they appear in pairs, almost as if they are born together. This finding is completely unexpected, as planets are traditionally thought to form in isolation around stars. The idea that rogue planets could form in pairs or groups is a game-changer for our understanding of planetary formation. It suggests that there may be an entirely new process at work, one that scientists have yet to fully comprehend. Further analysis of these rogue planets, particularly the massive ones found in the Orion cloud, has revealed another surprising detail. Many of them appear to have properties similar to gas giants like Jupiter. These planets, known as jumbo planets, have masses that are several times that of Jupiter and temperatures around 1000 degrees Celsius. This discovery raises another fascinating question: why do these planets exist in such large numbers, and why do they appear to be in pairs? Scientists are currently exploring two main theories to explain these strange objects. One theory suggests that these rogue planets may have formed in the usual way, just like any other planet, but instead of being captured by a star, they were ejected from their original systems due to a gravitational interaction. This would mean that these planets were once part of a star system but were flung out into space when they were young. The other theory posits that these planets never had a star to begin with. Instead, they may have formed in a region of the Orion cloud where there was not enough hydrogen to form a star, but the conditions were still suitable for the creation of gas giant-like objects. These rogue planets could have formed in isolation, without a parent star, and they may have always existed as free-floating worlds. As scientists continue to study these rogue planets, they are also confronted with the possibility that we are witnessing an entirely new type of planetary formation. It's possible that the Orion cloud, and other regions like it, may be home to a process of planet formation that we never imagined. If this turns out to be the case, it could have profound implications for our understanding of how planets form, evolve, and survive in the vastness of space. But rogue planets are just one of the many astonishing discoveries that the James Webb Space Telescope has made. Perhaps even more mind-blowing is the telescope's ability to peer into the very early stages of the universe's formation, revealing galaxies and objects that challenge everything we thought we knew about cosmic evolution. One of the most startling discoveries made by JWST is the existence of galaxies that are far larger and more mature than our models suggest should be possible so soon after the Big Bang. These galaxy breakers, as scientists have begun calling them, are galaxies that contain up to 100 billion stars, yet they formed just 500 to 700 million years after the Big Bang. According to our current cosmological models, there simply wasn't enough matter in the early universe to form such massive galaxies in such a short period of time. Yet, these galaxy breakers exist, forcing scientists to reconsider the very nature of galaxy formation. Could it be that our models of the early universe are incomplete? Could there be unknown factors at play, things we haven't yet discovered or understood? This is the question that scientists are grappling with as they analyze the data from JWST. It's clear that the universe is far more complex than we ever imagined, and the discoveries made by the James Webb Space Telescope are only the beginning. In addition to these galaxy-breaking discoveries, JWST has also unveiled a number of supermassive black holes that seem to have formed far earlier in the universe's history than we thought possible. One of the most intriguing finds is a black hole that weighs over 1 billion times the mass of the Sun and exists just 770 million years after the Big Bang. This discovery raises even more questions about the formation and growth of black holes, as well as the processes that drive their evolution. How did such a massive black hole form so early in the universe's history, and what mechanisms allowed it to grow so large, so quickly? The existence of these early supermassive black holes suggests that our understanding of black hole formation and growth is still incomplete. Could it be that we are missing key factors that contribute to the rapid growth of these cosmic behemoths? Are there processes at work that we have yet to discover, or perhaps entire classes of black holes that we don't yet understand? These are questions that continue to puzzle astronomers as they analyze the data provided by JWST and other telescopes. The revelations brought forth by JWST are not only reshaping our understanding of black holes, galaxies, and rogue planets, they are also challenging some of the most fundamental assumptions we've made about the universe's expansion. One of the biggest mysteries that JWST has brought into focus is the so-called Hubble tension. This refers to the discrepancy between the rate at which the universe is expanding, as measured by the Hubble constant, and the values predicted by the Standard Model of cosmology. The Hubble constant is a critical parameter in cosmology, as it tells us how fast the universe is expanding. According to the most recent measurements, the Hubble constant appears to be around 67 kilometers per second per megaparsec, based on observations of the cosmic microwave background radiation. However, other measurements, particularly those involving supernovae and Cepheid variables, suggest that the Hubble constant is actually closer to 73 kilometers per second per megaparsec. This discrepancy, known as the Hubble tension, has confounded scientists for years, and the observations made by JWST have only added to the mystery. What does this tension mean for our understanding of the universe's expansion? Could there be unknown forces or particles at play, such as new forms of dark energy or dark matter, that are affecting the rate of expansion? Or perhaps there is something about the nature of gravity itself that we have misunderstood? The answers to these questions remain elusive, but one thing is clear: the discoveries made by the James Webb Space Telescope are pushing the boundaries of our knowledge and forcing us to rethink everything we thought we knew about the cosmos. As we continue to study the data collected by JWST and other space observatories, we are coming to the realization that our understanding of the universe is far from complete. The discoveries made by JWST are forcing us to confront the limitations of our models and theories, and they are opening up new avenues of exploration that could fundamentally alter our view of the cosmos. It's clear that the universe is far more mysterious, complex, and wondrous than we ever imagined, and we are only beginning to scratch the surface of what is out there. In conclusion, the James Webb Space Telescope has revealed a universe that is full of surprises, planets that defy our understanding, galaxies that are larger and more complex than we thought possible, and black holes that seem to defy the laws of physics. As we continue to explore the cosmos, we must be prepared for even more discoveries that will challenge everything we think we know. The universe is vast, mysterious, and full of wonders, and with the help of JWST, we are just beginning to understand how little we truly know about the cosmos. Each new discovery brings us closer to understanding the true nature of the universe, and we can only imagine what astonishing revelations the future holds.